Hello, everyone. My name is Steve Studalski. I'm the platform manager at Galvanic Applied Sciences. Today, we have an applications training for the chlor-alkali industry. We will be discussing how to optimize online measurement specifically for the chlorine absorption unit. Chlor-alkali is an industrial process for the electrolysis of sodium chloride brine solution. This technology produces sodium hydroxide, hydrogen, and chlorine. The most common chlor-alkali electrolysis process uses a membrane cell. When saturated brine passes through the anode, chloride ions are oxidized to produce chlorine gas. After electrolysis, chlorine gas goes through a series of processing stages until the final product is ready. This includes cooling, drying, compression, liquefaction, and storage. These processes create off gas containing 1 to 8% chlorine that is routed to the chlorine absorption unit. The recycled chlorine gas is used for bleach production. Here is an example of what a chlorine absorption unit looks like. The gaseous chlorinated effluents consists of nitrogen, oxygen, hydrogen, and carbon dioxide. The gas receives wet scrubbing to reduce the concentration of chlorine venting to atmosphere and to form sodium hypochlorite. The chlorine absorption unit is also used to absorb chlorine during an upset until operations return to normal. The chlorine absorption unit faces several operational challenges. One of these challenges is sodium hypochlorite decomposition. This can occur from a low pH value if there's not enough caustic. Metals such as cobalt, copper, iron, or nickel catalytically accelerate decomposition. Decomposition also occurs from heat-producing side reactions. This includes disproportionation to chlorate and chloride with an intermediate formation of chlorite. The same effect occurs with disproportionation to oxygen and chloride. Another challenge faced by chlor-alkali plants is the formation of salts. Their limited solubility in the scrubbing solution leads to equipment blockages. Solid salts precipitate when carbon dioxide is present in chlorine, or when caustic is depleted so that the pH value drops below 12. It should be assumed that if all caustic is consumed, then all the chlorine entering the scrubber will vent to atmosphere. That's why excess sodium hydroxide should always be in the scrubber system. Certain chemicals such as sulfur dioxide, sulfites, and hydrogen peroxide can also react with hypochlorite. The reaction of hydrochloric or sulfuric acid with sodium hypochlorite will liberate chlorine gas. The solution to these challenges is to employ online process analyzers in the chlorine absorption unit. In fact, the World Chlorine Council offers specific guidelines for which instrumentation to consider. The minimum requirement would be to install analyzers that detect chlorine on the scrubber outlet. However, another beneficial measurement would be an online analyzer to monitor the liquid scrubber solution. As expressed by the World Chlorine Council, it's important to remember that pH is not a reliable indicator. pH only determines acid or base. This does not provide adequate information on the caustic buffer capacity. Solely relying on pH leads to unexpected swings, and the probe can easily foul in the harsh caustic condition. Galvanic Applied Sciences is in the unique position of providing solutions for both gas and liquid samples. On the left-hand side, you see our wet chemistry analyzer monitoring caustic and carbonate in solution. On the right-hand side, you see our tape analyzer monitoring chlorine gas. Now let's talk about how both of these measurements work. How are you controlling scrubber chemistry? Identifying sodium hypochlorite decomposition or salt formation. In our opinion, wet chemistry analyzers are the best for monitoring caustic and carbonate in scrubber solution. This allows for percent level concentrations to be measured to help optimize scrubber performance. Multi-parameter configurations can measure caustic, carbonate, and bicarbonate. Multi-stream configurations are also available to monitor complex scrubber systems. Several other compounds can be measured utilizing different analyzer configurations. Galvanic's AccuSeries analyzer monitors caustic following an approved ASTM method. Our analysis sequence guarantees plus or minus 2% full-scale accuracy and repeatability. This is our third generation wet chemistry analyzer marking 30 years monitoring caustic scrubbers. Our robust sample system and sample conditioning minimizes maintenance for operators. Wetted parts such as Kynar and Calres are selected to ensure optimal chemical compatibility with caustic. Now I'm going to turn things over to my colleague Peter, who will discuss the chlorine gas application. Peter, take it away.
Thanks, Steve. Hello, everyone. My name is Peter Cartmel, and I'm the platform manager at Galvanic Applied Sciences. Let's switch from liquid to gas. How are you currently monitoring chlorine in your scrubber and gas outlet? Are you only monitoring chlorine or combining it with chlorine dioxide? How often does the concentration approach permit limits? What's your analyzer's uptime? Does the analyzer accurately report the chlorine concentration? In our opinion, tape analyzer offer the best way to monitor low ppb levels of chlorine in the stack vent. This allows the operator to understand scrubber efficiency to make sure chlorine is captured by the caustic. Chlorine going out to the vent means lost profit by not being able to convert the recycled chlorine to bleach. Too much chlorine venting to atmosphere could also breach permit limits and result in expensive fines. Online chlorine monitor with ppb sensitivity provides trustworthy reporting capabilities for the plant. Multiple stream configurations are available for multiple scrubber vent outlets as well as for permitting monitoring. Galvanic's ProTech 903 analyzer monitors chlorine using a dry colorimetric method. Our analysis sequence guarantees plus or minus 2% full-scale accuracy and repeatability. This is our third generation tape analyzer, marking 30 years of field experience. We eliminate the need for calibration sonar by the use of cal gas generator mounted on the analyzer panel. A small volume of chlorine permeates and mixes with a carrier gas when calibration is required. This ensures a streamlined, hands-off operation of your chlorine analyzer. Thank you for joining us to learn how you can optimize your chlorine absorption unit with online analyzers. If you have any questions, please contact Galvanic's sales team. You can also reach out to Steve or myself. And as always, you can contact your local authorized distributors. Thank you and have a great day.